Now listen to a conversation between a student and a professor.
Hi, Professor. You got a minute?
Sure, Christy. Did you pick up your paper yet? I just finished grading them and I was really impressed with yours.
Really?
Of course, I loved your arguments. And what you wrote about farming for less than $10 a day, it really has incredible real-world applications. I can tell you put a lot of thought into this paper.
Speaking of real-world applications, that's sort of what I wanted to talk to you about, the student exchange program.
Oh, sure, absolutely. Are you thinking of going somewhere? That's a great program.
Well, I have a couple of places in mind, but I really have my heart set on Guatemala.
What draws you to Guatemala?
I think Guatemala would be the most relevant place for me. It would be perfect to go there so I can do some research about my ideas.
I can see where you're coming from, Christy. I think you have some good reasons. I hate to tell you this, but the exchange program in Guatemala is only for Spanish majors, and the Spanish department is usually pretty strict about that.
No, there has to be some way I can go. I've already done so much research about it. Guatemala is perfect for my research. It has the exact type of agricultural practices, economy, and environmental conditions I want to study and explore.
You make a fair argument, but have you thought of other places? I really wouldn't want you to get your hopes up since it's a program run by the Spanish department, and I can't remember the last time a student was able to go who wasn't a Spanish major.
That doesn't seem fair. Is there nothing I can do? They must have let someone go before who isn't a Spanish major, right? I mean, I know some Spanish, if that's any consolation.
Look, I want you to have the opportunity to go, and I agree that it could be an ideal place for your research. Since you are very passionate about going, I'll talk to the person in charge of the situation and see if they can find a way to accommodate you.
Really, Professor? Thank you. That means so much to me.
I think you should prepare a solid argument to present to the Spanish department just in case. Can you do that?
Of course, absolutely. I'll do anything. I'll be ready.
Okay, glad to hear it. Let me talk to the department and I will let you know if anything changes, okay?
Okay, thanks, Professor.
Now, answer the questions. 1. Why does the student go to see the professor? 2. Why does Christy want to go to Guatemala? Select 2. 3. Why might Christy not be able to go on a trip to Guatemala? 4. Why does the professor decide to help Christy? Select 2. 5. Why does the professor ask Christy if she has thought of other places to go? 'Now listen to part of a talk in an astronomy class.
So, I would like to continue our discussion about the moon, more particularly about the origins of the moon and how it was actually created. We talked about 3 possible solutions, more like theories, about how the moon was created. Can anyone tell me the name of one of these theories? Sarah.
Well, I do remember the capture theory. which proposes that the moon was located somewhere else in the galaxy until eventually it was kind of like captured by the Earth's gravitational pull.
Yes, and I'm glad you started with the capture theory because it's the easiest one to reject. Its primary drawback is that no one knows of any way that Earth could have captured such a large moon from elsewhere. One body approaching another cannot go into orbit around it without a serious loss of energy. Furthermore, if such a capture did take place, the captured object would go into a very strange orbit, rather than the nearly circular orbit our moon goes through today. Finally, there are too many similarities in composition between Earth and the moon. It's much more likely that the Earth and the moon were somehow connected at one point in the past. What was another theory discussed? James?
The fission theory. Like you said, the moon was once a part of the Earth, but somehow separated from it early in their history. But I remember you mentioned some problems with this theory too.
Yes, the fission theory suggests that the moon separated from the Earth, but modern calculations have shown that this type of splitting is nearly impossible. Furthermore, it is difficult to understand how a moon made out of materials from the Earth could have developed so many chemical differences from our own. And the third? James again?
Yeah, the last one is the sister theory. It claims that the moon formed together with the Earth, but also remained independent from it. This is why many astronomers once believed of other moons in the solar system too.
Yes, the sister theory was the dominant idea accepted by most astronomers in the past. But like the capture and fission theory, it had some problems, particularly when trying to explain how it could have such a lower density when compared to the Earth. Now, in an effort to resolve these apparent contradictions, scientists developed a fourth hypothesis for the origin of the moon, one that involves a giant impact early in Earth's history. This idea, known as the giant impact hypothesis, proposes that Earth was struck by an object approximately 1/10 Earth's mass, which is about the size of Mars. This is very nearly the largest impact Earth could experience without being shattered. Now, such an impact would disrupt much of Earth and eject a vast amount of material into space, releasing almost enough energy to break the planet apart. Computer simulations indicate that material totaling several percent of Earth's mass could be ejected in such an impact. Most of this material would be from the stony mantles of Earth and the impacting body, not from their metal cores. This ejected rock would then cool and form a ring of material orbiting Earth. It was this ring that ultimately came together and formed the moon. While we do not have any current way of showing that the giant impact hypothesis is the correct model of the moon's origin, it does offer potential solutions to most of the major problems raised by the chemistry of the moon. Most importantly, since the moon's raw material is from the deep rocks of Earth and the asteroid that hit it, the composition and chemistry of the moon is better understood and explained.
Now, answer the questions. 1. What is the professor mainly discussing? 2. How is the lecture organized? 3. What are some problems with the capture theory? Select 2. 4. Which theory about the moon is most likely true? 5. What does the professor imply about the sister theory. Six. Why is the giant impact hypothesis also problematic? Now listen, it's part of a talk in a geology class.
Geology is the study of Earth's crust and the processes that have shaped its surface throughout history. Heat escaping from the interior provides energy for the formation of our planet's mountains, valleys, volcanoes, and even the continents and oceans themselves. But not until the middle of the 20th century did geologists succeed in understanding just how these landforms are created. Plate tectonics is a theory that explains how slow motions within the Earth's interior move large pieces of land, resulting in a gradual drifting or spreading out of the continents. Plate tectonics is a concept as basic to geology as evolution by natural selection is to biology, or gravity is to understanding the orbits of the planets. Looking at it from a different perspective, plate tectonics is a way for Earth to transport heat efficiently from the interior, where it has accumulated, out to space. It is a cooling system for the planet. All planets develop a heat transfer process as they evolve. Now, Earth's crust is divided into about a dozen tectonic plates that fit together like the pieces of a puzzle. In some places, such as the Atlantic Ocean, the plates are moving apart. In other words, such as off the western coast of South America, they are being forced together. The power to move the plates is provided through a process by which heat escapes from the interior through the upward flow of warmer material and the slow sinking of cooler material. As the plates slowly move, they bump into each other and cause dramatic changes in Earth's crust over time. You know, when studying maps of Earth, many students notice that the coast of North and South America could fit pretty well against the coast of Europe and Africa. It seems as if these great landmasses could have once been together and then were somehow torn apart. The same idea had occurred to others, including Francis Bacon as early as 1620, but not until the 20th century could such a proposal be more than just speculation. The scientist who made the case for continental drift in 1920 was a German meteorologist named Alfred Wegener. Born in Berlin in 1880, Wegener from an early age dreamed of exploring. Later in his life, his interests turned more toward Earth's weather. He carried out experiments using kites and balloons, becoming so accomplished that he and his brother set a world record in 1906 by flying for 52 hours in a balloon. Wegener first thought of continental drift in 1910 while examining a world map in an atlas, but it took 2 years for him to assemble enough data to propose the idea in public. He published the results in book form in 1915. Wegener's evidence went far beyond the similarities in the shapes of the continents. He proposed that the similarities between fossils found only in South America and Africa indicated that these two continents were joined at one time. He also showed that similarities among living animal species on different continents could be best explained by assuming that the continents were once connected in a supercontinent he called Pangaea, from Greek elements pan meaning all and gaea meaning land. Wegener's suggestion was met with a hostile reaction from most scientists. Although he had collected an impressive list of arguments for his hypothesis, he was missing a mechanism. No one could explain how solid continents could drift over thousands of miles. A few scientists were impressed by Wegener's work and continued searching for additional evidence, but many found the idea of moving continents too revolutionary to take seriously. Developing an understanding of the mechanism, plate tectonics, would take decades of further research. Critics of science often point to the resistance to the continental drift hypothesis as an example to the flawed way that scientists regard new ideas. But there is a more positive light in which to view Wegener's story. Scientists in his day maintained a skeptical attitude because they needed more evidence and a clear mechanism that would fit what they understood about nature. Once the evidence was clear, Wegener's hypothesis quickly became the centerpiece of our view of a dynamic Earth.
Now, answer the questions. 1. What is the purpose of the lecture? 2. Why does the professor start the lecture by defining geology? 3. How is the lecture organized? 4. According to the lecture, what is the purpose of plate tectonics? 5. Why does the professor say this?
Born in Berlin in 1880, Wegener from an early age dreamed of exploring.
Six. According to the lecture, what evidence did Wegener find to support his theory of Pangea? Select 2. Now listen to a conversation between a student and a professor.
Hi, Professor. You wanted to see me?
Yes, come in, Anya. It's about the paper you submitted for your assignment. I'm afraid I'm going to ask you to do the assignment again.
Really? I'm kind of shocked. I mean, I worked so hard on that paper. Wasn't it good?
I can see how much work you put into it. In many ways, it's a very good assignment, but
I'm confused. If it's good, why do I have to do it again?
I understand that you're upset, Anya, but let me finish, okay? The situation isn't nearly as bad as you think. As I was saying, your assignment was well written and well researched, but it wasn't what I asked you to do. You submitted a review of one of the books from a reading list, but the assignment I said was to write an essay.
Really? I remember the assignment, and I'm sure it said to review a book from the reading list.
It did say that, but here, let me get the actual assignment and read it. Here we go. It says, review one of the 3 books on this week's reading list, and then write an essay that compares the arguments in the book with those we discussed in class. Do you see the difference? I wanted you to review the opinions in the book, and then write about how that differs from what we discussed in class. And you just reviewed the book and didn't address the second part of the assignment at all.
So you were using the phrase review a book in the assignment to mean something like study the book rather than write a review for the book?
Yes, that's exactly right. And as you are the only person who misunderstood the assignment, I don't think what I wrote was unclear, do you?
I see. Listen, I'm really sorry about my mistake, Professor. Can I submit a revised assignment next week on Tuesday or Wednesday?
Actually, Anya, it's only Monday, so I'd like it before the weekend, please.
Now, answer the questions. 1. What did the professor and student mainly discuss? 2. Why is the student confused? Three. Listen again to part of the conversation. Why does the student say this?
So, you were using the phrase review a book in the assignment to mean something like study the book rather than write a review for the book?
Four. Listen again to part of the conversation. What does the professor imply when he says this?
So, you were using the phrase review a book in the assignment to mean something like study the book rather than write a review for the book?
Yes, that's exactly right. And as you are the only person who misunderstood the assignment, I don't think what I wrote was unclear, do you?
Five. What do you think the student is most likely to do next? Now listen to part of a talk in a psychology class.
All right, let's settle down and start talking about everyone's favorite subject, sleep. And we're going to start with your circadian rhythm. So, a circadian rhythm is a biological rhythm that takes place over a period of about 24 hours. It's basically how we biologically experience each day. Our sleep-wake cycle, which is linked to our environment's natural light-dark cycle, is perhaps the most obvious example of a circadian rhythm, but we also have daily fluctuations. Now, does anyone remember a few other examples? Janet?
Yes, I think that your glucose level changes based on the last time you ate.
Yes, that's right. Anyone else?
I think they also mentioned heart rate and body temperature, but I forget the specific examples.
Don't worry about that, George. We will discuss these other circadian rhythms in much more detail later in the course. But for now, the most important thing to keep in mind about circadian cycles is that they are usually aligned with the outside world. For example, most people sleep during the night and are awake during the day. Now, one important regulator of sleep-wake cycles is the hormone melatonin. Melatonin release is stimulated by darkness and inhibited by light. When people have difficulty getting sleep due to their work or demands of day-to-day life, they accumulate a sleep debt. A person with a sleep debt does not get sufficient sleep on a chronic basis, and the consequences of sleep debt include decreased levels of alertness and mental efficiency. Interestingly, since the advent of the electric light, the amount of sleep that people get has actually declined. While we certainly welcome the convenience of having the darkness lit up, we also suffer the consequences of reduced amounts of sleep because we're more active during the nighttime hours than our ancestors were. As a result, many of us sleep less than 7 to 8 hours a night and accumulate a sleep debt. While there is tremendous variation in any given individual's sleep needs, the National Sleep Foundation cites research to estimate that newborns require the most sleep between 12 and 18 hours a night, and that this amount declines to just 7 to 9 hours by the time we are adults. If you lie down to take a nap and fall asleep very easily, chances are you may have a sleep debt. Given that college students are famous for suffering from significant sleep debt, chances are you and your classmates deal with these issues on a regular basis. Sleep debt and sleep deprivation have significant negative psychological and physiological consequences. Now, as mentioned earlier, lack of sleep can result in decreased mental alertness and cognitive function. In addition, sleep deprivation often results in depression-like symptoms. These effects can occur as a function of accumulated sleep debt or in response to more acute periods of sleep deprivation. Now, it may surprise you to know that sleep deprivation is associated with obesity, increased blood pressure, increased levels of stress, and reduced immune functioning. A sleep-deprived individual generally will fall asleep more quickly than if they were not sleep-deprived. Some sleep-deprived individuals have difficulty staying awake when they stop moving, for example, sitting and watching television or driving a car. That is why individuals suffering from sleep deprivation can also put themselves and others at risk when they go behind the wheel of a car or work with dangerous machinery. Some research suggests that sleep deprivation affects cognitive and motor function as much, if not more than, alcohol intoxication. Now, the amount of sleep that we get varies across our lives. When we're very young, we spend up to 16 hours a day sleeping. As we grow older, we sleep less. In fact, recent research indicates that by the time we are 65 years old, we average fewer than 7 hours of sleep per day. As the amount of time we sleep varies over our lifespan, presumably the sleep debt would adjust accordingly.
Now, answer the questions. 1. What is the lecture mainly about? 2. Why does the professor start the lecture by talking about circadian rhythms? 3. Why does the professor mention college students in the lecture? 4. What does the professor imply about the dangers of sleep deprivation? 5. Which of the following is an indicator that you might suffer from sleep debt? 6. Why does the professor say this?
In fact, recent research indicates that by the time we are 65 years old, we average fewer than 7 hours of sleep per day.